Hey everybody, thanks for coming back and watching this video with me today. So I made a video not too long ago about building an Amazon price tracker with JavaScript. And in that video I said that I'd pulled the code out of a bigger, more full stack project that I was working on. So in this video, I kind of just wanted to take that full stack project, take a look at the code and really help talk through my methodology of building out a full stack JavaScript project. But I'm going to basically break this video down into 3 sections. I'm going to leave time links down below as well if you want to just skip straight to them. So before I jump into those sections, I just want to explain a little bit about the architecture of this project and the decisions that I made, sort of the more high-level decisions I made building this full stack project. So first things first I'm going to talk about is the backend. Now, when it came to building a backend, I obviously needed to decide a stack that I was going to work with, being that for my entire career, let's say, I've only really done JavaScript. So for me, it was a very easy decision to use Node.js with an Express framework and MongoDB for my database. One of the main factors of me wanting to build this project is I wanted to really practice my skills in building out a traditional REST API. I still haven't learned GraphQL. It's one of the things on my to-do list to learn. So I thought, let's just compound my skills in just building a traditional REST API. And I came at that side of things thinking, okay, let's imagine I'm not building the front end. Let's just imagine for a second I'm a backend developer here, and I need to build this backend to not only work logically, but to be very easy to understand, very easy to query from the front end. So that was kind of my thinking behind building the backend. Now, for the front end, I decided to use the Ionic framework. At my job, we use mainly Stenciljs built on top of an Angular app to build our app that we put out to the world. But I thought for the sort of this type of project, I didn't want to spend a lot of time building individual components in Stencil, which is why I went with Ionic for 2 reasons. Number one, I wanted it to be mobile first. I wanted to make essentially a progressive web app out of this so it could be installed on phones or work on computers. And number 2, Ionic comes with a really amazing suite of pre-built components that are really easy to work with, that you just kind of link up data into and it just works. So I just wanted to use Ionic to get this project off the ground and sort of build out more of a sort of, let's say, MVP. And then before I even started building the UI, obviously I built the backend first, so I knew how all the stuff works over there. But before I even started touching the Ionic code, I took just a pen and paper, sketched out some just really basic sketches of how I wanted my UI to look, how I wanted the flow to be in the app, sort of getting from a login or a sign up page to a home page to a product page, just so I had an idea of when I was building it out what kind of pages and components I would need to work with. Then finally, I come onto the deployment side of things. Now, in this app specifically, I still used MLab to host my MongoDB database in the cloud. This also being that I haven't had a chance to learn Mongo Atlas yet, but seeing as Mongo did buy MLab, it's all in the same sort of infrastructure sphere, but I know very quickly how to work and integrate with MLab, so I just still decided to use that for a database. And the server code itself sits on a free Heroku dyno, so it works with a lot of, not hacking, but I had to work to get it to work with Puppeteer on Heroku. And then the front end, the app itself is hosted on Firebase. So again, the deployment of the app is a mix of MLab, Heroku, and Firebase. So now that I've gone over the main sort of overarching app architecture, let's just jump straight into the code and let's just start talking through it, and I'll explain my process. It's something that I found that has come up a lot in comments recently on more codey type videos that I've done. People want to really hear about all the decisions that I made when writing functions, and so I will really be going in depth here in this video, so don't worry and stick with me. Okay, so here we are in the Amazon price checker repo. So I'm going to go ahead and start with the server, so the back end, then I'll move over to the front end, and then I'll show you the app to show you how it all works basically, and also where it's hosted and what it's doing. So first things first, starting with the backend, a couple of months ago had kind of wanted for a while to build out a boilerplate, just REST server basically in Node. So I took a couple of evenings after work and I did that. And this project was then built on top of that. So I basically just got a very simple server.js file. This is where all my main dependencies and all my sort of main stuff is loaded into. Just sort of the central repository for all my models and all my controllers and all that sort of stuff. Here I've got linking up to my database. So here in this local version, I link up to my MongoDB instance that's running locally on my machine. But this is where I would link it to an external database, be it MLab or MongoDB Atlas or any other database that you'd want to use. You can link it up here. So in the setup flow of the server in Express, it then will then connect to the database. Just some basic config stuff like CORS requests, just turning on CORS that you can do a cross-origin requests. It's basically a very boilerplate server. Bringing my routing into the server, what happens in a 404 situation, and then just connecting and actually running the server with a little output just saying the API is running on what port and what time it started running. So this is something I realized that when I was trying to get this in the air and debugging it, I didn't know when my server was turning on. I didn't know how long it was up for. I didn't know if it had restarted, what that difference of how long it had run for before it needed to restart. So I just chucked that in very quickly and just string interpolation, new date, just so I get the date, the number that I can just convert into a time and work out, okay, it started at 10:05 and it then went down at 10:15. Okay, why? So that's basically it. That's the server file. That's what gets it up and running. Other basic stuff in here, I've got a README where I basically documented out all the routes and what kind of objects that the server is expecting to get. So I could have used Swagger, I could have used API Doc, but I didn't really want to do that at the time. That's something I could go back and refactor now. Not in this video, but now in this time. Now that it's all working. So basically I just have a list of all the different endpoints, all the different what they are, if they're posts or they're gets or they're deletes, and what they're expecting to get. So that's where all my documentation of all the endpoints is in the README. Proc file, this is needed if you're running or deploying your server on Heroku. Packages, gitignore, .env, not going to show you that one obviously. Middlewares, this file just exists for if I was using JSON Web Tokens. This is all my JSON Web Token config stuff. I'm not using them in this site, but it's there because that's from my boilerplate API server project. Logs is another thing I'm not doing. I did start building it in, but then I realized personal project, don't need to do logging, but I've got a folder there in case I want it. So to really get into the bread and butter of the server, I've got my routes, I've got my models, and I've got my controllers. So if you've done Node before, if you've built out databases and servers and stuff in Node, everything's model based, everything's done around a schema, everything's done with objects basically. So here in all my models I define all my collections in the database. So a user is going to consist of a name, an email, a password, when they were created, when they're updated, and they have an array of items. Similarly, I have an item model, which is a UUID of a single item and when it was created. So in my single item model, I have a name, a link, an image URL, a price, a target price, whether the user is following it, what the past prices were, and then what users are associated with this single item. The logic behind all of this was when I started building out the database, when I started building out all the server-side logic, I thought, I'm going to have a user, and I'm going to have an item, and that user and item need to be connected. So this is where I started thinking, actually, if I knew relational databases, this would be a lot easier to build because I could just build a table of users and a table of items and link them together. So I kind of had to simulate that or build that into this NoSQL. So on every item that exists in the database, it has an array of users that user ID is just pushed into an item. Another thinking behind this was I might have one item in the database that has 10 users that are following it. I don't need to replicate or scrape that one item 10 times for each separate user. I can just do it once. It can do all its work, and then when user A logs in, they pull the latest data. When user B logs in, they pull the latest data. So suddenly, when I really thought about the architecture, the central item in my server is the item that's being scraped. The users are just nodes of that item. Because originally I came into it thinking, oh, I'm going to have a user and it's going to have a load of different items and it's going to be a very centralized thing. But when I really started to think about it, I was like, no, the item is the central thing in this server. It's not the user. I then have a deleted model because this is something I learned in a previous job. Again, personal project, not keeping any data, but you never really delete anything. You just move it to a table of deleted because you might need to recover it. A user might say, hey, I've left my account, but I want to come back 6 months later. So, hey, well, how do you think Facebook do it? I will leave that there. I then have my routes. So all my routing here is divided into 3 things. I've got my user routes, my scraper routes, and my authorization routes. Auth routes are just used for logging in, basically. So it's one very simple thing. My scraper routes are all the stuff to do with products. And my user routes are, again, to do with logging in, creating, getting. This is more from, like, say, an admin side of things. So I built an admin panel, get all of the users in the database. This is more for if I wanted to build out an admin panel. If I wanted to start building data into this or statistics, I could start using these user routes. And then just simple stuff. I think this was also carried in from my boilerplate project. But then the real meat of this project, or this backend at least, is the controllers. In Node, a controller is basically a JavaScript file where all your logic is done. As I said before, maybe I could make these more modular. I have a lot of functions and a lot of stuff going on in these files that could be broken down into sub-controllers. So user controller, I've got get all users. I could break this down into an admin controller and an actual user controller. So I have all my admin functions and my user functions. And that's one thing I could do, like get all users. Why does that need to be in here? That could be in an admin controller.js. But basically, just these are all my basic functions. If you want to have a look at this code, it's linked down below. You can go in and have a look. You can copy this stuff. It all works very well. Doesn't really do much other than this one, update a user. So I am a user. I'm logged in. I go in and I get a new product. I need to then add that. That's not what it does. Deletes from DB. So yeah, user controller, not very useful. Scraper controller. This is where this is the big daddy of the functions. This is basically the site is built around this. Again, probably could make this far more modular than it is, but let's take a look at it anyway. So I bring in all my different models. I bring in a link to file system so I can. This is what I was doing for logging originally. I bring in Puppeteer, which is my big thing that I use here. Cron. So node cron or cron jobs are basically functions that the server can run. It doesn't need an exterior thing to tell it what to do. So here my logic was if I have a cron job that every 6 hours I go to every item in the database and I can then scrape the price of every item, that's probably what I should do. And then node mailer is here. I just thought, okay, if the item that the user has scraped, if they want to get it, I need somebody to tell the user, hey, this item that you're following has reached its target price. So that's what node mailer is there for. I thought originally I wanted to text them, but then I was just like, for an MVP, it's quicker to just shoot out an email. So then I start building my functions. So get all items. This basically goes to the database and gets me a list of all the items in the database, like all the single items. It's very quick. It's very easy. Then get single item. This is called from, it goes and looks at all these single items and it finds the specific item I'm calling from the front end. And it then sends that back to the client. Get a single user's items. So here, a user will say, hi, I'm logged in, I'm Ben. I need all the items associated with me. So I go to all these single items and I find it under the users array. Does that user ID exist on this item? And then I package those over, and send them back to the front end. Get all followed items. So this is allowing me to look and see what items in the database are being followed. Or as in, do they need to be tracked? Does their price need to be scraped every 6 hours? I think I set it to. First scrape. So now we're starting to get a lot more complicated with what we're actually doing to pull out the prices. So first scrape, basically, this is the function that runs the first time you add something to the database. So I'm a user, I'm logged in, and I need to add a new product to the database. This is the function that gets called. So I take from the user their user ID, because I want to know what user is initiating this. I need a URL. I need to know if they want to follow it, if they want to follow the price, true or false. And I want to know what the target price that the user is looking at. If follow is null, as in it's not a mandatory thing for the client, but if it's null, then it's false. Ultimately, I'm just going to assume that if the user hasn't said, I want to follow this, then it's going to be false. We then call the scraper function and we pass it the URL. And I'll show you that in a second. Once the scraper has gone and done its thing, it passes back an object, which is held in this result. If a result exists, then I basically will make a new item in the database, calling my single item model. I'll then save it in the database, and then I've got all my error handling that if that save doesn't work, and if it does work, I also save it in the items collection just to reference, just so I know where it is. And I send a message back to the user saying, it's all good, we found your item, we scraped it, it's in the database, we're off, we're going. And the catch block, basically, if anything happens, this could be a general error. It gets caught here, and obviously that's shown back to the user. Something went wrong. I don't want to tell the user exactly where and what went wrong because you don't know who's using your website. Similarly, if you're logging in, for example, you should never say to a user, your email was wrong or your password was wrong. You should be very, very vague because you don't know who's using your site. If you tell somebody immediately, your password was wrong, that's a good attack vector. That's somewhere the user knows that, okay, cool, so the email I've got here is working. I just need to work out what the password is. So you want to be very vague with messages that you're passing back to users. Update item basically will go and update the cron job. Say I've got an item that I'm tracking and I want to change the target price down to £50 from 100. This will then go and update that price on the item in the database. Change tracking, pretty simple. That takes the item that's being tracked and it just says Boolean track it or don't track it, basically. Delete item takes the item that the user has decided to delete and it just moves it over to the deleted table and just gets rid of it. But doesn't really get rid of it, but gets rid of it. So scraper, this is the core of this app. Basically, you pass it a URL. That's all it needs. And then it opens up a headless version of Google Chrome in Puppeteer. And then it just goes to the page. It waits. Now, lucky for me, the whole idea of this app is it's going to Amazon, it's scraping an Amazon page. 90% of the pages that I found on Amazon, DOM structure-wise, are all exactly the same. There's a couple of edge cases that don't work with this app yet. Stuff that's like on special offer, if it's got a countdown timer, if the price is going to drop, stuff like that. But for most things, like say if I wanted to go in and find an iPhone and just track the price of an iPhone, then this method will work for that. It basically goes in, it gets three things. The three things I decided to go and scrape. I need a title, an image URL, and a price string. And the thing with the price string is, so the string that Puppeteer pulls out of the DOM is actually a string. It's not a number. So I just very quickly go and number one, pass it into a number, and number two, in my instance, it's looking for a pound symbol, but if you're in America, it might be dollar. It goes and looks for that pound symbol and that string and strips it out because I can't pass pound symbol 299 into 2.99. You need to get rid of that string element. I basically just pass that back up to the rest of that scrape function. That's it. And then Puppeteer closes itself. This is the cron scheduler. So say this server is up and running on a server somewhere, be it Heroku or AWS or whatever, DigitalOcean, who cares? This cron job basically runs every 6 hours. Every 6 hours, it goes to the database. It looks at all the items that have the property following true, and it just then calls out and runs an update on each one. And the update is exactly the same. It calls the scraper with the link, and then it just updates in the database with that data that it's pulling in. That's pretty much it. And then it also goes to the user and it updates the price array, basically. What else? Send email. So send email is a function that is called when, say I'm looking for an iPhone and the target price I've set is £600, and it hits that £600. Well, that part of that check in that cron scheduler is, did the target price and the actual price match? If they do, then we're going to shoot off an email to the user. So we need to get the item ID. Then we need to find the users. So this is why the user becomes a part of that node of that item. I need to find the user or the users who have been tracking that item. And I need to then extract out what their email address is. So I ask for their email when they sign up so I can send them an email. Then I build out just a very basic HTML email. In this instance, I'm using Gmail to send it. There's instructions in the entire project README if you want to use Gmail to send your emails for you. And it just builds up a very basic email using string interpolation and says, hey, whatever your name is, the thing you wanted to buy has hit the target price, and here's a link to go and buy it. And that's it. That's the script. I did write the Puppeteer script with this guide, and I also found a couple of other things on Stack Overflow that really helped me out doing that. But that's it. That's the back end of this project. And it works really well. So let's give me a second and we'll jump over to the client side. Okay, so here we are in the client side. Did I update the README for this? I did. Oh my god, I'm really good. Basically, the client side of this app is built in Ionic. Ionic is a front-end framework, let's say. It's a JavaScript framework, mainly used for building native apps in HTML, CSS, and JavaScript. You can also use it to build progressive web apps or just build websites if you want. It's got a really good inbuilt styling system that you can make really good mobile-friendly, mobile-first websites, but you can also, if you decide to, bundle it all together and release it on Android or iOS on the App Store if you really want to. So it's what I use at work mainly. It's sort of like the overarching thing that we use at work to bundle up what we build into apps. But there's a lot of stuff here. A lot of it isn't necessary. The only stuff that is necessary in here really that I added was Firebase. So it's just adding in that functionality that I can use Firebase to host the static app. I guess the source, like that's what we really need to look at, isn't it? When you install and use Ionic, it builds all this for you, which is really good. To be honest, I think sitting here and just looking at code is kind of redundant, and I'll just show you the app instead. It'll make far more sense in that respect. So when you open the app, you have a login page that you can switch to a sign up page. I didn't build this. I took this from the Ionic Udemy course that I did to learn Ionic, made by Maximilian Schwarzmuller. One of the best programming teachers I've ever had. So this login page is taken from that project. So I'll just log myself in. And this will work really quickly now because I've woken up the Heroku dyno that this sits on. So this sits on a free tier of Heroku. So that means that if you don't use it, or if you're not using it all the time, it goes to sleep for about 30 seconds. So when you first log into this app, it might not work immediately. But here it is. This is it. So this is the array of items that somebody might be tracking. If I go into this, for example, I'm then shown the page. Am I following it? Can I remove it? What are the past prices? If I turn following off and turn it back on, I get that nice pop-up telling me that I'm now following something. But again, this is all a very, very, very simple Ionic starter pack. All the stuff you see here are Ionic components. There's nothing custom that I've built here specifically. If I go into this one, this is just a card component. If I remove it, are you sure you want to delete it? Yes, I am. So that's now gone, and it's gone from here too. Similarly, I've got a profile here. I only just have that for the logout button. But that's it. It's a very simple app. It's a very simple front end, but it's very satisfying to build something and then host it on Firebase and be able to download it and use it on your phone as well. Like, it's really cool. So that's the front end of the app. Doesn't really do much. It's basically just a create, read, update, delete. This, as you can see, because it's hosted on a dyno that's actually alive, the cron job doesn't actually work because the dyno's sleeping and the cron doesn't wake it up. But it's just semantics. But I have tested it running this project locally on my machine, and I've set the cron to run every hour, and I've left it running for about 12 hours, and it does get 12 prices. Being Amazon, they don't really change that much, but it would be nice to know that it does work properly on an external hosted server that is up all the time. Anyway, enough of me waffling. This is the GitHub repo, again, linked down below if you want to go and have a look at it, play around with this code. I've written out a README file, so I think everything that I've written out here should be pretty clear in terms of you want to download this, install it locally, play with it, build it to Firebase, install it on your whatever on your phone. Go ahead. If you have any issues with it, you can raise an issue, do a PR. That would be really cool to see some interaction. But yeah, so that's basically my first full stack JavaScript project that I built, both the back end and the front end. So yeah, back out to that camera, I guess. Whew, right, we're back. So I really love this project. It was so much fun to work on for me. And I also really genuinely feel that this is the first full stack project that I've actually ever finished, because I've started a lot, but this is the first one I've finished. So I'm very proud of myself for that fact. You know, I still feel I'm definitely missing quite a lot of stuff here. I'm definitely missing some, some better coding practices, some better ways of writing my functions. There's still work that needs to be done either on this project or in myself personally, but I still think I could turn up to an interview with this and say I built a full stack backend, client side, deployed it, it's in the cloud, here, have a link, go download it, go play with it. Like, I'm very proud of that. But I also think I am missing some stuff. I haven't done any unit testing on the front end, which is quite bad. I haven't done any unit testing on the back end. I also think I could probably refactor quite a lot of the code to do with the scraping portion. I could make that a lot more modular rather than just having one great big JavaScript file doing it. Another thing that I realized when writing this project is how much I love TypeScript. So on the front end, obviously in Angular, I'm using, in Ionic, I'm using TypeScript to build all my data models and, work with my functions and my code. It's very easy to understand. It's also what I work with at work. And then suddenly going over to the back end and writing everything in JavaScript loosely typed, I was really having a hard time writing the back end because I realized, wow, I really miss this TypeScript architecture. So maybe that was a meaning that I need to go and learn a new backend language. I need to learn something like Python, or I need to learn even Java at a basic level. Something that's a little bit more strongly typed for my backend. But if you want to have a look at the code for yourself, I've left a link for the repo down below, obviously. So go in there, jump around, have a look around, download it to your computer, install it. I've written out the README if you want to build and run this app locally on your machine. It's all the information should be there. If you have any issues, leave me a comment either here or on the repo, do a PR, something like that. You can get in touch with me. I'd love to help you out or hear your feedback about it. And if this is the first video of mine you're watching, or if you're new to this channel, if you haven't done so already, please go ahead and click here on my little face to subscribe. And if you enjoyed this video, then there should be a little window up here with another video that YouTube thinks you're going to enjoy. And until next time, thank you so much for watching, and I'll see you next time.